Welcome back to the Untangling Web3 podcast. In today's episode, we're diving into one of the most exciting frontiers in artificial intelligence, AI agents. Now, these aren't just smart tools or chatbots, they're autonomous digital workers that can plan, act, and learn on their own. From managing your inbox to powering self driving cars, AI agents are quickly moving from research labs into our everyday lives. So, let's try and unpack it all together. Alec, I bet you're excited for this one.
I am excited. I think I'm a bit cautious, but overall I am excited. I think we've been talking about AI for quite a while now, and it seems like there's always a new term or a new kind of hype coming out. And I think this is something that we've seen a lot of over the last 6 months. We actually had Colin Fitzpatrick talking about it, and they're using this term like a year ago, maybe. So before it became the booming word that it is today. But yeah, I'm definitely excited to go into it, maybe what it means, why it matters, and maybe try and explain some of it as well.
Yeah, it's crazy how long ago it feels now that Colin was talking about this, and now that's at the time wasn't really being talked about in most circles, and now it's like the only buzzword. If you look at all the kind of recent big tech company announcements and stuff talking about AI, they used to just be talking about AI, and now they're saying agentic AI all the time. It's like the newest buzzword. So yeah, it's a good one to get into.
And I think, yeah, when Colin started talking about it, my interpretation was, oh, it's just a little avatar that can, basically do a Google search. It can respond the way ChatGPT did at the time, but with a little face to it and looks a bit human, kind of like some of the sci-fi programs that you see, like Blade Runner. But yeah, should we go into it, like what we think it is, and why we think it matters?
Yeah, it's a good place to start. I think if it's just kind of defining it for ourselves, because when I was thinking about it and kind of researching for this episode, I had like an idea of what it was in my mind. The problem is it's kind of simple and complicated at the same time. So for me, in the simplest form, AI agents are basically just a wrapper around an LLM, around a normal, what we talk about as AI now, Gen AI. Language model, but you wrap it with additional tools and the ability to essentially become task oriented. So instead of asking it to, just summarize information or, help you write an email or something, it's now goal based or task oriented. So it can try and achieve a goal for you, right? That's kind of the ultimate thing. And how you get there, there's like tons of different ways to do it, and you can equip it with lots of different tools. But at its core, the AI agent is basically that. It's trying to achieve a task, right?
Okay. So even that, I find that kind of like a bit vague in a sense, right? I
Yeah.
find that kind of difficult to get my head around. And I think it's kind of like, to go back 2 years ago to when we were defining Web3 and all this kind of stuff, I kind of think of it in a similar light where we have this continuum similar to Web 1 to Web 2, where it's really hard to say where the line is, where an agent is, an AI agent is, and where one is not. And I think part of it is there's this label for sexy investment VCs to be like, oh look, we've got the new AI thing. Let's just to explain it immediately what it means, rather than be say some of the characteristics you said. We've got a wrapper on a model that enables us to do X, Y, Z, and has these tools. But yeah, I think really roughly I agree with you in that we kind of think about AI models as quite static, and
Mm.
agents are just a more dynamic form of that. Like they can take actions, execute workflows, trigger APIs, adjust behavior, and all this kind of stuff. They're just a bit more dynamic. They have more understanding of their environment. And when we kind of think of like the traditional OpenAI, it was just a context window of my prompt plus its previous static knowledge, and it would give me something and I would do something with it. And now we're kind of thinking of that window of interaction of the world being much bigger. Like you say, having these tools, these access to live information, the ability to basically be more autonomous and have more agency.
Yeah, I think I agree. When I said it, it's kind of simplistic, and it's also kind of a self-defeating definition because, well, if my goal is to write an essay that's overdue
Yeah,
for university,
exactly.
then it can definitely achieve that goal for you.
Yeah.
But yeah, it's basically for me, it's like anything that's a bit more complex than that, anything that requires either getting additional inputs from the outside world or putting stuff out into the outside world and doing kind of more complex things. That's where I think the line is drawn. And typically, when you look at like an LLM, um, that is, as you said, it's limited based on essentially the knowledge it's been trained on, right? And that's a big part of the move to agentic AI is you want it to have more capabilities and knowledge context than that, right? So, and also they're not always that adaptable on their own. If you just have an LLM, you're just interacting with it through OpenAI, through the website
Mm.
and the chat interface. It's not that adaptable to other types of tasks that you might be able to think of. So yeah, that's a big distinction for me.
And I think, yeah, when you kind of picturing this in your mind, you have like the foundational OpenAI model, and it's built on top of a knowledge base. And we can say that's kind of static, but it's really not, because they're obviously plugging more data into it, and it's learning based on your prompts and all these kind of things. But I think they're kind of, when we are to draw an architecture, in my mind anyway, of like an agentic AI, the system architecture should change. Like, it should be able to create its own links to new
Mm.
tools and pick, say, what APIs it wants access to based on not even just requests from itself, like requests from a user. Sorry, it can basically derive what it needs to link to based on a really simple input and create more complex inputs from that. But again, this stuff is so vague. It's just kind of a more dynamic version of the static LLMs that we've become very used to over the last 2 years.
Yeah, exactly. I think one of the best ways of describing it, I think that I've seen, or kind of ways of thinking. Again, you kind of need a diagram for this topic, unfortunately, because it's the, as you said, the architecture, that the agentic architecture is the key thing, right? It's how you build stuff around an
Mm.
LLM, just a simple LLM. But the way I think about it is, okay, people try and solve problems using LLMs all the time. Like we said, a simple example, finishing my essay on time. But people do more complex things, and a developer, like a classic developer, might be able to hook up to the OpenAI API, right? They have an API that you can trigger events from in response to, or you can use it as part of an existing workflow. And often they get called AI workflows when you have an LLM involved. The big difference between all of that and what people mean by agentic AI, I think, is that whenever you have a workflow, you have a human that's defining
Mm.
how that workflow works, right? You have a human deciding what's the logic that is going to use the LLM. AI agents essentially just give that whole logic defining process to the LLM and say, okay, I'm going to give you a problem and you're going to decide the steps that you take to solve it. That's like the big distinction, I think, when you move to AI agents.
And that makes sense from like an enterprise perspective, right? Imagine trying to sell this 3 years ago and being like, someone's going to give an initial action to this agentic AI, and then it's just going to go out onto the internet, start sending money, start, opening APIs, retrieving information, and all this kind of stuff. That's really scary. Like, no company wants that kind of liability. So it makes sense the approach they went for, where it's just kind of, request an answer, and then the human does something with it. Like, write me an essay, even write me a code based on these API keys I have, but I will be the one that's kind of liable if anything goes wrong, because I'm the one that's going to copy paste that code and run that code and do something with it. But now we're in the age where everyone's trying to be the new sexy toy on the block, and they're taking a bit step further. Maybe they're trusting the models a bit more and saying, okay, actually, you're going to be given some directive, don't know what it is, and you're going to go out and start actioning things, because now we feel a bit more comfortable that you're not going to mess around. If we give you access to some keys and give you the ability to, basically have payment rails and send transactions and stuff,
Yeah.
you're not going to dump 1 million Bitcoin over here and all this kind of stuff. But yeah, it's quite exciting. I think the real edge here is the fact that it has a bit more agency. It can do things itself. And the real cutting edge stuff is, what can it do? How can it actually interact with the world? What tools, interpreters, whatever you want to call them, are basically creating that translation layer between the foundational model and everything that's going on in the world?
Yeah, exactly. I think you've been ahead of the curve in this, Alec, because you've been talking about adding these payment rails to AI since like the start of the podcast. And I think, in those early days, it kind of sounded like a bit of a pipe dream, but now it's very much a reality. Like, I think, Coinbase, for example, have started implementing payment rails for AI. So it's very much happening. And yeah, I think it's obvious why this is blown up as a topic in the last kind of 6 to 12 months. The impact it's going to have is obviously going to be big, because if you can think the space of problems you can solve with a normal LLM, well, then if you go and equip it with other tools, it's going to be able to solve a huge, much bigger problem space than you have already. And as ever with AI, there's huge predictions. Like, I've seen things like 5 billion in 2024 to an industry size of like more like 50 billion in 2030. I mean, I think that's probably in a conservative estimate, right? I think
Damn.
this is going to be huge.
So like a 9 times market growth in 6 years. That is bonkers.
Yeah.
I think I kind of understand why. Like, you could argue that the limiting factor with AI right now is that you have this human in the loop that has to check things, is liable for things, and a human can only work so fast. They're not 24/7. Obviously, like, AI has taken what a human can do and times 10 any productivity. Write me an essay based on these things, do the code to do this. But in a world where it's AI interacting with AI, how we think of like the economy, commerce, communication, it is going to just I don't think we'll be able to comprehend it in 10 to 20 years time. You see these like crazy stories like 3, 4 years ago where it's like, oh, they put two AI models in a room and they made their own language, and within a minute, no one could understand what they were
Yeah.
saying, but they were obviously transacting something useful. It's going to be that kind of thing where we won't understand the global economy, in my mind, in like 10 to 20 years, because
Yep.
the economy is going to be based around AI interacting with AI, because that's the most efficient and effective way. And that's why there's these predictions on such huge economic growth. Yeah, I think we'll see what happens, I guess.
Yeah, I mean, I've seen in the last few weeks a bunch of, I think it's Shopify, I might be wrong, but there's basically a few different kind of platforms around online commerce who are shifting to, we expect to be, receiving money from you via an AI. Your shopping will be done via an AI in the future, right? And they're actually gearing up for that future. So, instead of having all that decision anxiety when you want to buy a new jacket or something, it's going to know your preferences and it's going to go out and buy things for you. And I still can't quite get like that little leap in my head of like letting someone else do my shopping for. I don't like getting Christmas presents that are clothes
Damn,
from other people, right? I can't imagine how that's going to work. But that's the kind of thing that these big companies are already moving towards and expecting, aren't they?
you're easy, mate. Your model is just a medium black t-shirt,
Yeah.
like same thing every week. But
Yeah.
yeah, it is bonkers.
I was gonna say, I give the easiest AI agent jobs ever, so it's fine.
Exactly. I can understand it for things where it's like food shopping, easy to do, buy milk. That was the classic IoT example. It's going to be hooked up to your crypto payment rails, and when your milk's running low,
Mm.
it's going to automatically buy your milk. That's crazy. But the idea of this being like the interaction layer for buying clothes, and I think it's kind of scary. Like, I think it takes a lot of the power and decision making away from humans, and we can't understand things. And when things go wrong, how are you going to explain this stuff? But yeah, we've got ahead of ourselves. We were just meant to try and define what it is, and maybe
Yeah.
we can go into some of the background and history and context for all this stuff as well.
Yeah, and I think when you think about the history of AI agents, I would say the AI agents is just the last piece of the history of AI, right? It's the most recent thing that's been happening in AI, and because of how we defined it, and I think this kind of slightly vague definition that you have to apply in this case, um, you could argue that there's been a bunch of milestones in the last kind of 50, 60 years that they would fall kind of under this definition of agentic AI. It's like computers that could automatically make decisions based on a bunch of external tools and context and things. So when we've covered AI in the past, we've covered that full history. So I don't think we need to do all of that. But if you look at something like the IBM computer
Mm.
that beat Gary Kasparov in the chess game, that's an example of solving a kind of non-text based problem. It's a different problem that it was able to do with a bunch of extra different context. Similarly with IBM's Watson, I don't know if have you ever seen it, the episode of Jeopardy where IBM Watson
Yeah, yeah.
competes. It's so good.
It's
It's
so impressive. I think like it. We don't. Yeah, you say you don't. We don't need to go into too much detail, but I think the earlier agents were like, again, it kind of gets to this Web 1, Web 2 thing. We're really rigid. They followed
yeah.
rules. They didn't adapt very well. Like good at chess but terrible at real life, right? So when the rules are very defined, the model's very defined, easy, but
Yeah.
not so impressive when we talk about like really complex, abstract, maybe unquantifiable models sometimes for the real world. Like even Eliza back in like the early days, 1960, whatever it was, seemed really impressive, but it was just mimicking language. Like there was no real kind of
Yeah.
understanding of nuance there. And it's hard to know what understanding is, right? This is the problem with AI. It kind of gets so philosophical a lot of the time. But yeah, Watson's a good example. AlphaGo is a good example of when it started to really, understand nuance, understand risk, which is really quite complicated when you think about it, understand
Mm.
strategy and all these kind of things. But then, like we said, when we started talking about, OpenAI and ChatGPT, in the early 2020s, like their big leap was this conversational ability, like the ability to have human prompts and understand nuance in language and patterns in language and be able to like create useful outputs using that. And also like task chaining was another big thing, and like a thing we've seen in the last year that kind of relates to this agentic AI kind of development and trend is the integration with external tools as well. Being able to take
Yeah.
what's been done before, have the foundational model that understands language, understands patterns, and plug that into a tool that say getting lots of data to create useful outputs.
Yeah, I agree. I think you can kind of just use the early 2020s as the starting point for AI agents like that we know of today, in many ways because they're so deeply embedded into the LLM model, right? It opened up the space of language that it could process. That you can
Mm,
define tasks now. So it's everything. All the AI agents have been based off that, partly because it's being so usable as well, right? If you're going to make the kind of holy grail of general purpose agents that can go and break down any task you give it, and if you give it the right tools, it can go and achieve that goal, or at least get you most of the way there. Then all of that is being built on the most successful version commercially of language processing, which is LLMs themselves. So yeah, that's I would just you can go back and research the whole history, but just call it like 2020 2021. That's pretty much the starting point of what people talk about now as AI agents. And yeah, you mentioned, I think we'll get onto the specifics of how they work in a minute, but yeah, that chain of thought or chain of reasoning model for how LLMs work, because that's pretty recent. That's only in the last kind of, I guess, year to 2 years that's been
mm.
around. But for anyone who doesn't know what that is, if you now go and use like ChatGPT, and you can see it will now typically show you the reasoning process it's going through. Like if you use deep research, for example, it'll break down the steps it's going through for that research based task. So that's kind of the analysis of your ask of your problem,
Mm.
like go and do some research. It breaks down, okay, well, I need to look at this, I need to look at these websites, I need to synthesize this type of information and put it out in that format. So you can already see it in a simple narrow problem set, but yeah, this is now being widened up to kind of basically anything that you can give it a tool to go and do.
Yeah, I find that process of seeing like exactly what stage, that's so satisfying. But
Yeah.
again, a lot of that comes down to context window, like the amount that these models can keep track of at any one time. And early on, that context window was quite small, so it was more like I saw it being described as like quite synchronous tasks. So single
Mm.
shot question answer, like why is the sky blue? But it answers it. But then if you ask like, okay, well, why is it sometimes not blue? It would just start again because it wouldn't be able to keep tabs on everything it already knows and they the question before, because then the context window becomes too big for it. But as the context window grows, we're starting to see, say, and this relates to AI agents as well, these kind of asynchronous tasks, the agents kind of running in the background, monitoring systems, reacting to change, kind of like a digital co-worker. Whereas before, like I keep coming back to this, but I think it's really important. We think of AI as these containerized windows of interaction. You ask a question, it gives you an answer, you go do something. But more and more, we're seeing it be an open world where it's like a digital assistant. You give it an agenda or even just a name, and it will go away for a day, an hour, whatever it is, and just do lots of things in the background that you wouldn't be able to have thought of in advance yourself. But as it's kind of, finding bottlenecks, finding problems with its, say, initial kind of idea of how to do this, it starts to create these decision trees and it goes off at a tangent. Maybe, a paperclip factory ends up destroying the human race.
Yeah, it's a good way of thinking about it. Actually, I hadn't really thought about it in the asynchronous way, but yeah, it makes sense. Like you're duplicating what you can do in a given window of time. So the ultimate problem you're solving with agents is just time, like things you don't have time to do, or things you want to spend that time doing
Mm.
other things with. So yeah, I like that. Shall we get into how they work? Because I think at a high level, they're actually fairly straightforward to understand if you don't go too deep into the details. So
Yeah, at a really shallow surface level, so
yeah,
easy to understand. There's like a PhD in like deep learning right now being like, no, they're freaking not. Go on, mate, you
yeah.
go.
It's nice. So if you the experts have kind of condensed things down for us normies into what they call the React framework,
Okay.
which doesn't help for developers because React framework means
Yeah.
something totally different in front end development. But we'll just ignore that. And React standing for reasoning and then action. So that's the two main, I guess, domains in which these AI agents work. So the reasoning part means they have almost like a perception. You can give them an input, a prompt, much like you do for ChatGPT. It's the classic way of using LLM. You can create an instruction or give it a problem to solve. The reasoning is that kind of chain of thought we've just talked about. So it can reason not just how to write an essay. In this case, it can say, okay, you give me a complex problem, and that may be very complex, this problem. Then it reasons, okay, what are the steps I need to take? And it will write down and think, in its own memory, essentially, what steps do I need to take? So that's the first part, is reason. And then the next part is action, which kind of speaks for itself, but that's where it goes away and takes those steps, implements things, and then hopefully gives you the right answer at the end, or some answer. So that's at the high level, that's the key of how AI agents work, right?
Today's episode is sponsored by the VChain Foundation.
Now, we often talk about how emerging technologies like blockchain have the potential to revolutionize sustainability, and VeChain is at the forefront of this green movement with initiatives like VBetterDAO. Let's take a closer look.
Imagine tracking small actions, like recycling, at low cost, making them valuable assets. These verified records build a massive collective impact, benefiting people through their own actions. Sound a bit complex, but VeChain made it fun. Explore our apps at vbetter.com.
VeChain's goal is to power a new era of sustainable solutions. So if you've got an app idea or just want to earn rewards for small, sustainable actions every day, go check out vbetterdao.com to find out more. And now, back to the show. And I saw like another way of describing this is like a pipeline of, like, let's say the steps similar to what you're saying, where the first step was around perception. So it's taking in data from sensors, maybe from APIs, like understanding what's going on online, could be Twitter, sentiment, all this kind of stuff. Then the second stage is what you mentioned there is cognition, using models to reason, plan, understand really what's going on, like all this, the many huge amounts of data that it's taken in, actually turn that into something useful, maybe a plan, a strategy, like you were saying there, based on a request. And then, the final step is actioning that, performing tasks, sending an email, booking a meeting, writing some code, developing something, that kind of thing. But yeah, it sounds really simple when we're saying like that. That's kind of like how humans act as well, like how humans interact. So
Yeah.
I guess we're explaining this in a simple way because it kind of seems more intuitive to humans. And I imagine, again, there's probably some expert listening being like, that's really not how it works.
Yeah, exactly. I think for our small brains, it's kind of smooth brains. Even that's the
Smooth.
easiest. That's the easiest way to think about it. And again, that reasoning part is super complex. Like how you actually get it to reason is beyond the scope of my understanding right now. I don't know anywhere near enough detail, but at least you can see it working, right? If you're using an LLM, the action part is kind of easier to grapple with because that's actually more about just connecting it with the real world, with, as you said, APIs, with data, with real-time data, for example.
Mm.
So that's the difference between, in the past, like a year ago, we were saying, well, it's a big limitation of LLMs that they don't have up-to-date information, or they're not trained on up-to-date information, so they don't have access to it, right? So you've seen, we can kind of get into retrieval augmented generation, or RAG, as well, when you can just kind of have an LLM look at a certain data set that you've got, like when we talk about a private company building a kind of second brain for its based on its own
Mm.
internal documents. That's like a very small subset example of what an AI agent is, right? You're giving it a certain set of inputs, but yeah, it could be literally anything. It could be code, computation, calculation,
Mm-hmm.
or other LLMs, right? It can be other agents, which is the kind of future that you're hinting at, right? I think that we're going to get to is actually what we're going to connect it to most likely, as well as just Google, is a bunch of its friends, its other AI agents in the ether that are
Yeah.
talking to it and helping it solve certain parts of problems as well.
Yeah, I think like one of the kind of the early advancement. I kind of think of this as two parallel streams of advancement. One is like the foundational model, the brain that sits in the middle, the one that comes up with the strategy, the cognition, whatever, all that kind of thing. And we're seeing like there are a few big players, maybe 6 or 7. We did a whole episode on it last week, a couple of weeks ago, on the advancements and how these things have, they're more performant, higher context windows, all this kind of stuff. And there's kind of like two branches on how companies are approaching that. One is just throwing a huge amount of compute to the problem.
Mm.
That's kind of like the X Grok style, which we didn't even talk about in the last model. They're just throwing so much compute to the problem, and it seems that they can just brute force it and create really good understanding responses, whatever, with a lot of compute. And then you've kind of got the DeepSeek model, which is basically kind of breaking down questions and answers and patterns into a more like smart way, efficient way. And like I said, DeepSeek is extremely performant based on the amount of compute. Like you can run the DeepSeek R model on a MacBook, which is bonkers, like really bonkers to think that that's possible. And like these companies, it's getting better and better. And it seems like the cost of compute, the cost of cognition is coming down and down, which is like kind of commoditized in a lot of ways, which is quite exciting. And then the other thing is the tools built around that big brain. And you've got the inputs and the outputs. What am I seeing? What is this information that's being fed into my brain? And what can I actually do with that information when I come up with a strategy? And I think that's all to play for right now. Like all the wrappers you're talking about, the specializations that we're talking about, that is kind of where I see there's a lot more maybe opportunity for startups. They're like specific use cases, specific angles, specific assistance, all this kind of thing. But yeah, they're the two big streams I kind of see being developed right now.
Yeah, exactly. And that's a good point, right? Because there are lots of different types of AI agents, but I'd say another way to dice them up in general is that you have, I guess, specific or special purpose AI
Mm,
agents that are people. Again, people like you see it like marketers, for example. There's loads of marketers currently building AI agents for marketing, right? That can go and send cold emails and write copy because actually that's kind of stuff that the LLMs are pretty good at already, and it's a case of just
mm,
connecting them via Zapier or something like that, right? So that's kind of simple. And then the other branch is people are pushing for the general purpose AI agent that can kind of understand and do anything. That we'll talk about that a bit later when we kind of survey the landscape. But there's one called Manus at the minute that's come out recently that everyone's kind of going a bit crazy about because it's meant to be general purpose and it can handle a lot of things and it's doing some interesting things behind the scenes for how it does that. But again, to like in some of the categories you have of just like simple agents, this shows the difference between what I think LLM based agents are in 2025 versus kind of what they've been. So you have like these what they call simple reflex agents, which can just do
mm,
simple things, respond to inputs, and they're not actually that clever. Like like a special thermostat or something. Like if the temperature drops below this
mm,
value, then turn the temperature up in the house, like that kind of thing. It's very simple, but that's an example of almost like an AI workflow more to me, right? Where it's there's logic that's been programmed by a human. I've decided that's the behavior I want,
mm,
and then you have everything all the way up to these learning based agents that can learn and improve over time, where you have the agent itself, the LLM in the middle of the agent is defining what the logic is, the control logic. So it's not, the control logic isn't if this happens do this. The control logic is like a dynamic thing that's being
mm.
updated. It's the LLM deciding, okay, I had these instructions last time, this kind of didn't work that well, so I'll change the instructions, try again, that kind of thing. So they're very iterative when they work as well.
I think it's quite important to understand the different types of like these agents based on your use case. So, like, I
Yep.
mean, we haven't mentioned all of them, but say a HR agent might be a goal-based hire. Like, that's another type of agent, a goal-based agent. Like, get me 3 CVs by the end of the month; they're all super appropriate and make sense for this job and that kind of thing. You might get a utility-based agent, which is another example, which is like pick the best candidate from those CVs that the first agent's been given. And then you might have a learning enabled one, which is like improve this process over time or help, say, attach to an individual, an employee, and improve their learning over time. And like when we're kind of thinking about this, you have the kind of philosophy there's a general agent that can do all those things perfectly, but more and more we're seeing these specialized agents and kind of thinking about this multi-agent world in which you'll have, say, those 3 specialized agents I just talked about. Say the goal-based agent that finds people, the utility-based agent that picks the candidate, and the learning-based agent, and they're all specialized in their very own like
Mm.
specific ways, and they interact with each other and kind of feed off one another because they know that, say, they can take over the next bit and that's their specialty. It's kind of like what we think experience right now with like globalization, capitalism, all this kind of thing. No one person does it all. We have very unique specialisms, say geographically or kind of whatever sense, and we rely on other people to be very good at the thing they do.
Yeah, it's a really good point. I think I also want to touch on the utility based agents thing as well because
Mm,
it's really interesting because how you train like a traditional neural network or an LLM itself is not to go into all the detail, but it does use something called like a cost function or utility function where every time it's improving the model, every time you're doing this training and trying to get an output based on a set of known inputs and outputs, then it'll give you an answer and it essentially rates that answer. And all these kind of weights in the neural network, they get updated based on how expensive that was, how costly that answer was, how close it was to the correct answer. And that's how it gets updated. And the very
mm,
same thing is actually happening now with AI agents in the space of like, how do you solve a problem? So when you give it a problem, I said it'll do the reasoning, it'll break things down into steps. But obviously there's like so many different combinations of steps that you could take for any given problem. So it will build its own kind of network of thousands and thousands of paths that it could take to go and solve this problem. And then over time, as it solves more and more problems, it will decide what's the best path for solving
mm.
that problem. What's the best set of instructions I should follow as the LLM, as the AI agent to go and do that. So it's kind of it's the kind of how they're learning to be better at solving tasks as we go. So it's very meta, right? Because we train the AI agents this way, and now they're updating their own processes like that, which is a bit spooky.
And that was one of the interesting things, right? When OpenAI and ChatGPT initially came out, it's like people were giving negative feedback. So they were saying like, oh, it's actually our models are actually kind of performing worse over time because people are saying, giving down thumbs to good answer and up thumbs to bad answers, and like feeding in wrong data sets and all this kind of stuff. And like you say, more and more, we're not trusting humans to necessarily do the validation. We're maybe trusting models to validate it. And there's easy ones to validate, like say a DeepSeek model might be like, the function that I'm trying to optimize for is cost or cost to compute or energy. That's very easy to do. Like basically, we can work out how much computations involved, fairly easy for a model to do that. But in terms of like quality of the answer of like how good is an essay, like that's really quite difficult. That's very subjective. Like how do they monitor those things and measure those things? And yeah, maybe we'll get into that, but that's quite a complex one.
Yeah, exactly. Should we just survey a couple of the major ones that people will have heard of, I think, because that, again, will make it a little bit more concrete. So I guess the one that beyond Colin and kind of some more niche kind of companies, I think people started talking about AI agents a lot more when OpenAI brought out Operator, right? And I think it's still in like a research preview, essentially. I don't know if you can access it fully, but essentially, yeah, this is their, again, it's almost like it's not like a full bells and whistles version of an AI agent. They're very good at productizing. They're rolling it out slowly and carefully, but it's essentially what we've been describing. It's ChatGPT powered with additional capabilities, right? So you can build virtual assistants off them. You can automate kind of business tasks based on a set of rules like that. The OpenAI operator model, an agent, is kind of one of the very first steps. I don't know if you have any thoughts on that one.
I've seen I think there's so many companies that are trying to be the new, kind of disrupt and have their own AI agent right now. Like the funding involved is crazy. I think it's like based on what you just said, it's important to highlight that all the major companies like the Anthropics with Claude and Gemini and all these kind of things, they all, even in Microsoft, they all have their own play for enterprise level AI agents to basically replace either researchers, developers, administrative staff, operational staff, whatever it is. They're all making big plays to hit big institutions and enterprises on that. But then you have a lot of smaller companies, like I said, they're basically just taking the foundational model from these big companies, which obviously they should do. Maybe DeepSeek, because it's so cheap and private and all this kind of stuff. And they're building this wrapper and these tools that is effectively targeted towards creating a new AI agent. We've got Crew AI, AutoGen. They're all doing very different things. First, like customer support is quite an obvious one. Like software development is another big obvious one where these things can have huge amounts of impact because 24/7, super efficient, incredibly patient. Like it makes sense to have these customer agent bots that, even if it's just to get rid of or, deal with 99% of the really simple queries, and then you push the 1% to humans that then can answer those questions more effectively with the time they have.
Yeah, and there are like a bunch of essentially agent platforms now, right? Which is, I think that's a marker of where we are right now in 2025 as to where we were when Colin mentioned it, because when Colin talked about it in that episode, we also talked about there was this developer who's quite famous on X, on Twitter, for like, he was building agents on his own. Basically, he was like building agents that could spin up websites based on talking to Siri. Like he'd basically turned Siri into an agent, which was really cool, and like everyone was mind blown. Now that kind of stuff is what is being productized by lots of these companies you mentioned, like the Crew AIs, AutoGen, for example, LangChain. They're trying to build systems to make those AIs. And as we mentioned earlier, Manus, I think that's a really interesting one because, everyone, I say, is getting very excited about that being a general purpose AI agent builder. And that is the way it's working and the way they've achieved that is interesting. Like, because it's basically exactly what you were saying just before, Alec, right? They have like a bunch of different agents working in concert when you create one of these like kind of bigger agents, right? These general purpose agents. So they have like one agent that does the planning, that takes the task and does the reasoning. And then it has like 4 or 5 different agents underneath. One is like for managing memory, so what parts of a conversation or context it remembers. One is for searching for information in real time. One is for, various other things, API connections, right? So it's like it's completely compartmentalized it, and everyone's getting quite excited about that.
Can I say, I think that is such a huge play. Like we kind of talked about
Mm.
very specific use cases, and you can like get really excited about this stuff like healthcare agents, content creation agents, customer service, coders, all this kind of stuff. I think one of the biggest plays is having this kind of like centralization points, because these models are going to change constantly, right? The models are going to be constantly improving. And then if you think of that as the brain, and these companies just developing the tools around the brain, as the models improve, the tools that are built around the brain, they might need to replace the whole brain. That might be complicated for the company. The company could go under, whatever. That's a lot of dependency on these foundational models if something goes wrong, for example. So I kind of see like the idea of having a degree of flexibility, interoperability, like this translation layer, like you kind of mentioned an example there. Another really good example is AWS. Like they have this solution called Bedrock, where you can effectively define the solution architecture, say the data inputs, the knowledge base, say the queries, what you want, and then you just plug and play and select whatever foundational model is hot and sexy right now. And I think those kind of like applications are, you look at AWS, one of the most successful systems in the world right now for software development and solution architecture. Like we're seeing a similar things where there's going to be such a plethora of foundational models and tools being developed constantly. One of the big money plays is to be the aggregator of all those things that a user can come in with and be like, I'm going to choose the model that I like. I'm going to choose the prompt I like, the knowledge base I like. And if I want to change it, you've got the solution where I can just plug and play and change to the new hot and sexy model. So I think, yeah, that's a really exciting play. And a good example is AWS Bedrock. If you haven't checked it out and you are building these things, have a look, because it's so intuitive to use it.
Yeah, that's like, I think that's such a great point. Like the holy grail is going to be not just it being general purpose in what it can do, but also having like maximum flexibility of what models you can use and what systems you can use, having kind of universal integration. Speaking of which, I think that's actually a really good segue onto kind of the next thing we should definitely cover on AI agents, which is another acronym, MCP, Model Context Protocol. So that's, again, even more recently than AI agents, that's become like the newest of the new buzzwords, right, in the last kind of few months. And to put it simply, it's a protocol and framework that helps part of this AI agent workflow that we've been discussing, right? It helps with the action part. So when you're connecting your agent to the outside world, at the minute it's like 2000 or what, 5 or 6. There's like USB-A, USB-B, you've got all these other weird and wonderful cables, and you always got the wrong one in your bag. Essentially the way people describe MCP is like the USB-C for AI agents, right? It's going to be a universal way of connecting agents to external sources that everyone can use, and everyone's just loving it, right? Everyone's going crazy for this.
Yeah, I think like an example that I've seen talked about in the kind of a similar light is that AI systems today are like pre-smartphone gadgets where every integration is bespoke, and this MCP is like Bluetooth that kind of has this common architecture, this common communication protocol that allows all these different agents being developed completely isolated, completely separately for very specific use cases, sometimes to plug and play, access tools, databases, services, all communicate in the same way. I guess the key thing is that these standards get adopted and all the foundational models and all the tools and AI agents are built to those specs. But yeah, when we talk about this world in which I want to choose an agent and then plug into a database and define my specific use case, and if that agent's no longer the hot topic, I can just plug and play something else. You need things like these. You need these communication standards, effectively, that everything is kind of judged by, I guess.
Yeah, it's a really interesting one, because when you talk about standards, like, yeah, most successful technologies need standards. Like the Web 2 needed standards for how HTTP works, right? All of that is publicly standard. All the encryption we use online has to be standard and publicly known, and so everyone can use it in a common way. And I think it's probably going to be, I think personally, MCP will be one of the fastest adopted standards in history, just because the whole point of using an agent is that you're not meant to put the human back in the loop, right, while the task is being solved. So you don't want an AI agent to have to go and do an API integration. Like that's something that, okay, maybe it's going to be possible, but it's like it's adding complexity where it doesn't need to be. And you want to be able to say here to this agent, go and solve this problem, in the knowledge that it's going to be able to communicate with whatever it needs to, which is exactly what MCP is doing. Is basically saying that whole headache of all the weird and wonderful mismatches between different systems, this should be taken care of by MCP. You can just fire at it the prompts you need and hopefully get the right answers. So yeah, it's going to be, I mean, obviously it's going to be adopted quickly. I think because it came out from Anthropic and OpenAI, one of their biggest competitor, arguably immediately added it to their website and their
Yeah.
standards and said, "Yeah, we're happy to use this," because they know the power of interoperability and having the global standard that everyone uses.
Well, it's an interesting one because we talked about like the USB-C standard and all this kind of stuff and the universal charging ports, and Apple resisted that for so long because they
Mm,
kind of had this monopoly. And my instant reaction was, surely these companies will resist that. But I think the point is that foundational models are no longer the hot topic. The topic is the tools and the AI agents that are now being built. And for any of these companies to be competitive, they have to be as plug in and play, as ready
yeah,
to integrate with all these tools as possible. So whatever the standard is, they're all jumping to be, the leading model that is plugged into these standards because it's all about the tools now. It's kind of funny to be like,
yeah, yeah.
foundational models don't matter anymore. It's about the tools the foundational models are built on that really is exciting people, which is crazy to think of. This has only
Yeah.
been around for 2 years as well.
Well, and when you've got such a crowded marketplace for the models themselves, there's enough ways that people are already using to try and differentiate between each other, and it's a fierce enough battle between them. You don't want to go and put up a walled garden around yours because everyone's gonna be like, "Well, no, why would I bother?" Right? Because yeah, the tools are going to make this model much more usable, even if it's not quite as good on the benchmarks. It's going to help me do what I need to do faster and easier 99% of the time. So
And I think a big part of that is as well is that what we've kind of seen is that the foundational models, the upfront cost for a lot of these foundational models is so huge. Like it takes so much money, so much time, so much energy to really build and train these initial foundational models. And then once it's done, a year later, the price for someone to just copy paste that foundational model or do it in a slightly more efficient way is like 20 times cheaper. So maybe the companies starting to say actually the foundational models are good enough now that average IQ is like 110 or something like that, so higher than the human average. So they're functional enough to replace a lot of, say, human productivity, human labor, human intellect, whatever. Now the real money maker is in the specific tools that we're building on top of. And maybe that's where they're seeing the impact. Like you saw what happened with DeepSeek when DeepSeek came out with its free model. Alibaba did the same thing. I
mm,
think the big Western, US AI giants right now are being like, actually it's going to be really tricky for us to monetize these foundational models when the Chinese companies are just bringing out something as effective for absolutely free open source that anyone can run. So maybe the real money maker is these AI agents that can replace individuals, but we just got to build the tools to make sure that it actually works. Kind of scary, kind
yeah.
of exciting, unsure what to feel about it.
Yeah, exactly. It's like it almost feels like everyone's going to have to go for a platform play again. Like, we have software as a service for all
Yeah.
these big companies. That's how they got it so far. You want to become the platform for building agents, right? And not have to compete on what model they're using underneath. Like, give the user the choice, but you just need to make it as easy as possible to create really effective agents. So yeah, it's going to be interesting to see how it plays out. I mean, the impact is obviously going to be huge. Like we talked about the impact of AI at length, and I think anything we say for AI goes again here, but like tenfold, right? Because now we're talking about it doing all these crazy things, like doing your shopping. It's
Yeah.
almost like finally the AI is on the other side of the coin for the consumer as well. Because for years we've been advertised to buy AI or recommender systems, and you have Amazon saying, "Would you like to buy this again on a recurring basis?" And now we're going to be putting an agent in front of that and saying, "Yeah, you can handle that. You can say no to Amazon when you like, hopefully." But
Yeah,
yeah, it's what are you
exactly.
worried about the future with agents, or are you excited about it?
It's hard. I think like because I'm in the space, I feel excited. I think if I was someone that was, I don't know, one of these jobs that's going to be disrupted by agents, say like marketers or something like that, or social stuff, like very, kind of, I guess the sectors that are very information in, information out. Say if something goes wrong, it's not the end of the world. Like it's not like a nuclear red button style. I would be slightly worried. I think that we're seeing AI agents very targeted towards support centers, call centers,
Yeah,
maybe like all any kind of supportive, like kind of informative things like that. I'd be very worried. But because we're in the space, I find it quite exciting because like the things that they can do and the kind of how pervasive they are in life is becoming more and more extreme. Like we're even seeing Alexa Plus is now the new thing. Like imagine Alexa. That's one of the most hotly used AI systems in the world. There are hundreds of millions of users of Alexa. But it's so dumb. Alexa Plus is now being rolled
yeah,
out. Imagine Claude is now going to be built into Alexa. Imagine the intuitive responses that you get from your prompt right now being built into Alexa. Like, it's going to be absolutely game changing. I think like the productivity and the ease of day-to-day life that's going to come from this is going to be so incredible that we can't even imagine what the next 10 years look like. I think there is a question around governmental response to this and what's going to happen in terms of employment, unemployment. I think we're going to see unemployment shoot through the roof because, the classic kind of response from governments when, the economy is not doing too well is to lower interest rates so people can invest more and then get more jobs. But when the reaction to lower interest rates and people having more money and more debt and more loans and all this kind of stuff is then to buy more CPUs, that doesn't correspond to more employment. So what's going to happen there? So I think, excited and nervous, I guess.
And daunted, yeah. I think I'm kind of in a similar headspace with it. I think there are some really interesting. I think there are huge benefits to AI agents that are actually narrow focus. So I know I've been banging on about general purpose AI agents, and that could be really useful for the people who can use them well. But having a narrowed scope again of an AI agent, so narrowing what it can do for safety reasons means you can siphon it off for specific tasks that are currently are take too much manpower to do essentially, right? And there are plenty of things that aren't quite. There's kind of a sweet spot between how critical the task is and how much of that task you need to do, like what the volume of requests for that task is. So there's obviously going to be applications in things like healthcare, for example, where if you can pick certain non-critical tasks, maybe paperwork based type stuff.
Yeah.
But again, it's about how much do you limit the capabilities, the sign off type limits of an AI to do things. Like you can limit some menial tasks, but you also don't want it like doing all the prescriptions, for example, right? Because that's where you don't want any errors to happen. So I'm kind of it's going to affect basically most industries. I think it's probably good to have a high touch kind of high nuance job where people still want people involved because there's a risk,
definitely,
like high risk jobs as well, right? Like where you need a human to take on some of the risk, right? Because that's a whole other conversation with who's going to bear the responsibility for when things go wrong, like with self-driving cars, that kind of stuff, as we always say. But yeah, it's going to be interesting either way.
Yeah, I saw some economists say that like most politics right now is left and right, labor versus capitalism, that kind of thing. And say more and more it's going to go in when AI interacting with AI and all the money is controlled by AI. It's going to become humanist versus AI focused, and like that's going to be the new political domain, which is really interesting. I think overall, like it's obviously going to have huge ramifications, positive ramifications for like productivity, for food creation, for healthcare, for education, all these things that are really maybe like basically kind of quite inflationary right now. I think that we're going to understand and be accountable for less and less of our lives, for less and less of like our systems, like complex systems especially. I think the real game changer, and it's kind of obvious, is like when we start to tie this in with robotics. And when you can buy a robot for $5,000 and it costs £1 a day of electricity to run, and you're also plugging in these intelligent AI systems on top, what does that mean for us as a civilization? Like I'm reading Isaac Asimov's robot series, and I've already read Foundation, and it's kind of like quite dystopian. Oh, it's dystopian and utopian. You can find like elements of both. I think it's exciting. I think I am overall positive about what's going to happen. I just think we can't possibly imagine what 20 years looks like from now, which is a bit crazy.
Yeah, I think that's actually such a good point that I can't believe we haven't really got into until now. But like when we talk about the tools that AI can use, we're still just talking basically about software at this point, right? Like everything we've covered is AI agents only really use software. When you bridge that gap to the physical, that's when some of the scary stuff can happen because there's a ton of stuff that you could automate that is low risk, like perfectly suitable to this stuff. But once it becomes economical and the cost of giving AI agents bodies, like physical bodies, then that's where the S will hit the F for sure.
What was the quote from Colin that I really enjoyed? It was like, if you think the size of the market for smart cars, for autonomous vehicles is big, wait till you see the size of the market for human labor. And I was like, it's getting there. Right now, we produce 50 to 60 million, I think, autonomous vehicles a year. When we're getting to the scale where we can start to produce humanoid robots to that level, like our society is going to completely change, and how we interact with technology, how we interact with one another is going to completely change. But we've been putting off for a long time now. We are going to do some episodes on robotics. I've been finally convinced Jack, because obviously I love this topic so much. So yeah, we're going to do a few episodes on robotics and talk about, say, the impacts and what's going on, and hopefully get some leading experts. I'm trying to line up to speak about it as well.
Yeah, so tune in the next few weeks to discover which of Alec or I has been a robot this entire time. Answers on a postcard. Votes, please. Thank you. So on that bombshell, yeah, we'll say thank you for listening. You can join us next time to untangle a little more Web3.